And now it is the assignment for the section 7, 8, 9 and 10. So assignment 1, which of following are monotone sequences? Sin n 1 upon 1 plus n square 2n plus minus 1 raised to n. Number 2, if Sn Tn are decreasing bounded sequences, and if Sn is less equal Tn for all positive integer n, then prove that limit of sequence Sn is less equal limit of sequence Tn. The next one is find limit of sequence n raised to minus n minus 1 into n plus 1 raised to n. Then number 4, if sequence Sn is 10 raised to n upon n factorial, so find positive integer n such that Sn plus 1 is less than Sn. And then the next thing is prove that limit of the sequence 3n square minus 6n upon 5n square plus 4 is 3 by 5. Then 6 n square upon n minus 7 square minus 6 is 1. Number 7, if Sn converges to 1, then Sn raised to half, that means square root of Sn converges to 1. Find the limit of square root of n into square root of n plus 1 minus root n. Then 9, let limit of sequence Sn minus 1 upon Sn plus 1 is 0, then show that limit of sequence Sn is also 1. Then next, prove that limit of 1 plus 1 by n raised to n plus 1 is E, and moreover that limit of 1 plus 1 by n plus 1 raised to n is also E, and then limit of 1 plus 2 by n raised to n is E square. So this is assignment 5, and the assignment 6 is that number 1, give example of sequences such that Sn diverges to infinity, Tn diverges to minus infinity, and Sn plus Tn diverges to infinity. Then Sn diverges to infinity, Tn diverges to infinity, and Sn minus Tn converges to 5. Then number 2, find limit superior and limit inferior number 1, the sequence is 1 2 3 1 2 3 1 2 3. The next is sequence sine of n pi by 2. The next one is 1 plus 1 by n raised to n. The next one is if sequence Sn is bounded sequence of real numbers and limit inferior of sequence Sn is m, prove that there is a subsequence of sequence Sn which converges to m. So we have done this kind of property, something like this. The next one is let a and b a sequence of real numbers and for each positive integer n let Sn to be a1 plus a2 plus an, Tn to be modulus a1 plus modulus a2 plus modulus an. Prove that if Tn is a Cauchy sequence, then Sn is also a Cauchy sequence. So complete these assignments, and we have finished or completed the chapter second.